Good morning, this is your Stat Sensei, Mr. Spensei, and this video will be covering categorical variables and graph assignment 2.1. So which of the following describes a continuous variable? A continuous variable is one that can accept all fractional values. I'm going to use the word all here, add that to that. So all fractional values or decimals or all decimals. Discrete, on the other hand, and we'll talk about that in a moment, but discrete, on the other hand, because it's a continuous variable or it's a discrete variable, and the discrete variable, and I think I misspelled that. Yeah, discrete variable is one that is counted numbers. Now, I know you can already see the answer, but please listen through this. So in this case, it says a number of items sold. Well, guess what? That means I can count them. We're talking about the number. That's the key word right there that tells me that that is discrete. All right. Oh, they're selling 5 items. They're selling 10 items. They're selling 100 items, but they're not selling 1.37659 items. So this one is discrete. We're not looking for discrete. We're looking for continuous. The number of apps. Once again, there's that keyword number. Hopefully, you're not downloading part of an app. You're downloading an entire app. So an app, the number, once again, the number, we're talking about counting. That makes that a discrete. So both of these first two are discrete. The third one I know you can already see is the answer. And the reason it's the continuous is it says the diameter of the tree trunks at an evergreen farm. Well, the trunk could be 1 inches, it could be 2 inches, or it could be 2.35647958. It could be any decimal value or any fractional value. So consequently, diameter, and typically speaking, all measurement, generally speaking, measurement, not counting, but measurement is going to be a continuous variable. So the answer choice to the first one is C. I want to continue on. The number of baskets made by a basketball player. Well, once again, we're talking about the number. So the fact that it says number lets me know that that is discrete. And besides that, you didn't make 1.36 baskets in a basketball game. You either made one basket or you made 2 baskets or whatever. You made a whole number, a counting number, and counting numbers are discrete. Now, this last one, which is the reason I really wanted to go through all of this, is a bit tricky. The shoe sizes of all shoes on sale at a department store, because you can have half sizes. You can have 12, well, 10, 10.5, 11, 11.5. But can you have 10.137? And the answer is no. So because these can be counted like that, even though they're counting by halves, even though it's weird, this is also a discrete. It's not continuous because it's not all decimal numbers or all fractional values like you would have with height and weight in any measurement. So height, weight, or any measurement is going to be a continuous variable. All right. Data will be collected for the following variables, which can be considered discrete. In other words, counted data. All right. And the word number comes into play as we saw up above. All right. The height of a person. Well, this is a measurement. And the fact that it's a measurement tells me that this is continuous, so it is not discrete. The next one, the weight of a person. Guess what? It's also a measurement. I don't even need to write it down again because I have it right there. So I'll put a little ditto sign. So measurement, the weight is a measurement. So it's discrete. It's not, excuse me, these are continuous. They are not discrete. The length of a person's arm. Guess what? It's also a measurement. All measurements are continuous. So that's not it either. The time it takes a person to solve a problem. 3 minutes, 23 seconds, 0.479. All right, guess what? Time is a measurement as well. Right? Time is a measurement as well. If you've ever seen an Olympic clock, you know it gets very specific. So that is also a continuous variable. All right, must be the last one, and it is. The number. Oh, there's that word. We know how many books a person read. We can sit there and go, they didn't read 3.675 books. They either read 3 books or they read 4 books. They either completed them or they're not. This is not a continuous variable. This is discrete. And one of the key words to help you recognize it is the word number. All right. The following table shows data for the 8 longest roller coasters in the world as of 2015. Which of the following is a categorical variable? All right. So this is a categorical. Categorical is different than quantitative. All right. It's easier for me to talk about quantitative. Quantitative are usually some measure. All right. It's usually a measure of some sort. So let's look at these real quickly. Length, guess what? That's a measurement. Speed, that's a measurement. Height, measurement. This is also a measurement. All right. So when I look at this, I go, well, those can't be those. Those are measurement. Type, guess what? That's an attribute. So type would definitely be a categorical variable. And continent would also be a categorical variable. They didn't have continent listed, so continent can't be my answer. So the only one that's not a measurement that's categorical that's listed is type. But please note, continent is also a categorical variable. All right. Which of the following cars about cars in a school parking lot will allow for a collection of a set of categorical variable? How many blue cars? That's a number. So that's a discrete variable. That's not really a category. Could be. I'm going to put a question mark. That's possible. Let's see if there's a better answer. What are the gas mileage in miles per gallons of the cars in the lot? Gas mileage. They get 6.3 miles. They get 7.3. They get 23.7. They get 42. These are quantitative. All right. This is a quantitative variable. And I'm going to also say that this is probably a quantitative. And the reason it's a quantitative, it's keeping up with the number. How many is a number? So that's tends to be a quantitative variable, and we're looking for categorical. So I'm thinking that's probably not going to be A or B. Both appear to be quantitative. What are the weights? Ooh, we're definitely taking a measurement. We're taking a measurement. This is quantitative. All right. It's not categorical. It's an attribute. This one's tricky up here because it mentioned blue. However, it's how many blue cars, which makes it a quantitative. What is the number of cars in a lot with out-of-state plates? All right. Once again, we're talking about number. Just like here, we said how many. What is the number? Because it's number, it's a measurement. It's a quantitative, making this also a quantitative variable. All right. What are the colors of the cars? We're not asking about numbers. We go, oh, we have a red car, a blue car, a yellow car, a green car. We have colors, not measurement. So the best one for categorical or grouping would be this one. The rest of them are measurements. All right. So E, because it's a attribute, it's the colors and not the numbers or the measurement. Numbers and measurement tend to fall into the quantitative category. All right. Number 5. Data were collected on 100 United States coins minted in 2018. Which of the following represents a quantitative? So in other words, some sort of measurement or count. We're not looking for a attribute or color. Well, the type of metal used, well, that's an attribute. So this right here is a categorical variable, and we're not looking for categorical. We're looking for a quantitative variable. The value of the coin, well, the coin could be a penny, 1 cent, 5 cents, 25 cents, 10 cents, 50 cents, $1. So the value of the quant is a measurement. So because it's a measurement, this is probably going to be my answer, and we already know it is because it's highlighted. Let's go through the rest of this. The color of the coin. The color of the coin, that's obviously a categorical because it's an attribute, so it's not that. The person depicted on the face. Once again, it's a category of coin. Lincoln, Jefferson, FDR, um, George Washington. I'm not even sure who's on the 50-cent piece anymore or on the dollar. So this is those are categories, they're not measurements. The location. All right. So we have the Denver Mint, we have the San Francisco Mint, we have the Philadelphia Mint. Location is a attribute. It's not a quantitative or measurement variable. So the only one that has a measurement is value. And we said that, hey, it could be a penny, a nickel, a dime, a quarter, 50 cents to a dollar. So our best answer choice is for 5 is B. Number 6. Oh, I love it when the lights go off in here. Excuse me for just a second. Whee! No lights coming back on. There we go. All right. So a study was conducted on 3 types of home siding and the type of damage done to the siding by woodpeckers. Each hole made by the woodpecker was classified as either a drumming, which is territorial, foresting, and I think it should say foraging, or nesting. The following bar chart shows the relative frequency of the holes for each type of siding. All right. Okay, so we're looking at this and we see relative frequency. Now, it's really important to notice this is relative frequency because this is in percents. So this is basically saying 25%, 50%, and 75% up to 100%. And by the way, these are segmented bar charts. And so with clapboard, we have, about 60% associated with nesting. I don't know what that is, but call it 5% with foraging, and the rest 35% with drumming, etc. Then we have groove plywood and non-wood. So those are types of statements. Which of the following statements is supported by the bar chart? The proportion of holes created for drumming is the same for all 3. Well, let's look at drumming. That's the light one. It's like, no, the proportion is not the same. Definitely non-wood had more drumming and groove plywood had the least percentage. So that's false. That is easy because we're working with proportion. Proportion is the percentages. The proportion of holes created for drumming is greatest for groove. Well, drumming was this, and we go, no, it's smallest for groove. What's greatest for groove is the foraging. So that's false. The proportion of holes created for drumming is least for groove plywood. And when I look at this, I go, yeah, that proportion is definitely smaller than this. I'm not sure what that is, but maybe this is 10%. This is maybe 30%, 35%. And this right here, I don't know, 70, 80, 70%. So definitely the proportion. So that one is C. Moving on to number 7. A sample of 100 students from Liberty High School and a sample of 60 students from Central High School were asked. So notice, this is important. We have a sample of 100 from Liberty and a sample of 60 from Central. So we have 2 different size samples. That's going to be important. All right. We're asked what they plan to do after graduation. Responses fell into 5 categories: 4-year university, community college, join the workforce, join the military, or undecided. The results are shown in the following bar chart. Yay. All right. So we see the 4-year college, 20%, Liberty, 30%, Central. And by the way, once again, we're dealing with relative frequency. So these are percentages. So this is 5%, 10%, 15, 25, 25, 5, 10, 15, 20, 25, 30, and 35%. But nothing got over 30%. So which of the following is supported by the bar chart? For Category 4 university, the number of students from Central High School was 10 greater than the number of students from Liberty. All right, this is tricky. I cannot just sit there and compare these one for one. I have to actually do some math. Now I can say that the percentage it has a 10% greater percentage, but remember, Liberty High School had 100 students and Central High School only had 60 students in the sample. So let's find out what looks like. So we'll set this up as a percentage. And anytime you work with percentage, you're going to set it up over 100. So for this first one, we're going to go for A, we're going to go 20% over 100. Percents are always over 100 in case you forgot that. Equals, well, how many students were at Liberty? 100. So when we multiply that out, and we're just going to go 20 times 100 divided by 100. Sorry for the glare. 20 times 100 divided by 100. And we go, oh, for Liberty High School, it's 20. We actually had 20. All right. When we go to Central, Central was working with 60 students, but we have 30%. So 30% over 100%, because once again, percents are always over 100, equals some value over the total number of students. So we're going to go 30 times 60 divided by 100, and we go 18. So this ended up being 18. Well, the number of students from Central High School was 10 greater. No, it's actually even less. The percentage was 10 greater, but the number was not. And the key word there is the word number. All right, moving on to number 8 or 7B. At Liberty High School, more students selected four-year university than any other activity. Well, let's look at Liberty. I can look at the percentages and go, well, this is Liberty. And I go, you know what? No, more people, I know this percentage is greater and it's at the same school. So Liberty is definitely going to have more students that went to community college than four-year college. So more students went to community college than four-year college, and just the same percentage went to the military and workforces 4 years. So that one's false as well. So these are gone. For category join the workforce, the number of students from each school was equal. The percentages were equal. All right, what I need to do if I want to know what actual number was, and I'm going to go ahead and do this, is I go, well, it's 20%. So 20% over 100% equals X over, and Liberty had 100 students. So it's like when I multiply 20 times 100 and divide by 100, because I'm multiplying these two numbers on the diagonal and dividing by the third number, I'm going to end up getting 20 for Liberty. When I go to Central, it's going to be the same percentage, 20 over 100 equals 60, X over 60, because this is a total. So I'm going to multiply those two on the diagonal, and I find out that I end up getting 12. So the number is not the same. I actually needed to calculate it. At Central High School, the same number of students was selected four-year university and military. All right, so let's look at Central High School. Where's military? Well, I can look at this and go, you know what? The percentages aren't even the same, so I know I don't have to worry about it. But just to check it out, to prove it to you, we'll go ahead and calculate this. So we already know that it's 18 chose four-year college. We already calculated this. Let's do the military. So for Central, well, once again, we're working with the percent, and it's 20% right here. So 20% over 100% equals X over the total number of students. When I do that, I end up getting 12, and 18 and 12 are not the same, so it can't be that. So it better be this last one. For category undecided, the number of students from Liberty High School was 4 greater than the number of students for Central High School. Well, that means I'm going to have to do some work because I don't know what these are. So this is both set at 10%. So 10 over 100%, because 10% over 100%, percents are always over 100, equals the total number, X over the total number of students. When I do that, 10 times 100 divided by 100, I end up getting 10. When I go to do it for Central, I have still 10%. 10% over 100 equals X over 60 because that was the total number of students. And when I do that, I get 6. 10 minus 6 is 4. And that's what it says. It was 4 greater. All right, number 8. The following bar chart shows the relative frequency of rain for 30 days. So 25%, 50%, 75%, 100%. Please remember that relative frequency is percentages. All right. And we have 4 regions. Which of the following statements is not, please note the word not, supported by the bar chart? Region D had the greatest percentage of days. This is a true statement, and we're looking for false statements. So it's not that. Because region D definitely had the greatest. Region B had the least. That's also a true statement, but we're looking for false statements. Region A had more than 15 days of rain. I'm not sure what it had. Let's just say 50, I don't know. I know that's over half. So let's just say 55%. I'm just guessing. Maybe 60, but let's call it 55%. It's over 50. So 55% over 100%. Well, how many days were we talking about? The total number of days is 30. And I go, well, 55 times 30 divided by 100 equals 16.5. That is more than 15 days. That's a true. And even if you'd said it was 50%, you would have gotten 15. And he's like, oh, well, I know it's more than that. So yeah, that's a true statement. And remember, we're looking for false. Region C had more than 25 days of rain. Well, I already know that that's not the case, but let's just say this is 30%. All right, let's act like this is 30%. And if we had 30% over 100% equals X over the number of days, 30 times 30 divided by 100, we get 9. And we're supposed to have more than 25 days. No, we had more than 25%, but not more than 25 days. Because remember, that's a percent, not a day. So this is false. And guess what? We wanted false answers. All right. Okay, moving on. Number 9. Which of the following the following pie chart summarizes the results of a survey given to airlines about the primary reason for flight delays. 15% was due to delays or due to overbooking, 8% due to runway closure, 5% other, 2% equipment failure, and 70% are due to weather. So most delays, or 70% of the delays, are due to weather. Which of the following is supported by the pie chart? The reason given most frequently was runway closure. So it is supported, means we're looking for true statements. This is false, not that. Runway closure was only 8%. More delays were caused by weather than by all other reasons combined. And the answer is, yeah, that's 70%. And if I add up everything else, it's going to add up to 30%. So this plus this plus this plus this adds up to 30%. 30% is less than 70. So yes, that is my true statement. So moving on. Number 10. In a certain school district, students from grade 6 through 12 can participate in a school-sponsored community service activity. The following bar chart shows the relative frequencies of students from each grade who participated in the community service activity. All right, so once again, we're working with percentages, okay? And we don't know how many 6th graders there are, and we don't know how many 7th grades there are, all right? Or in 8th, 9th, 10th, 11th, and 12th. The greatest number of participants was in 9th grade. We don't know. There might only be 100 9th graders, and there might be 1,000 11th graders, all right? We don't know the number, so the key word is number. If they said the greatest percentage, that would have been true, but because we don't know the number, we can't say that that's true. All right, and we're looking for is supported, and this is a false statement just because we don't know. The number of participating students in grade 6 was equal. Oh, once again, here's the key phrase. Number was, in this case, was equal. Well, guess what? The percentages are equal, but we don't know. There might be 600, there might be 200 sixth graders and 100 seventh graders. We don't know the answer to that. So this is also false and we're looking for true. The relative frequency of all participating students in grade 6 through 7 was 0.60. Sorry, can't add percentages. Unless they're on the same bar, you can't add percentages. In other words, if this went up like this, we go, oh, this was boys and this is girls, we could add those percentages because they're in the same bar. But if they're not in the same bar, we can't add them. So that's false. Grade 12 had the least relative frequency. Yes, they had the smallest percentage. Relative frequency is percentage, and they're saying they had the least percentage. That's a true statement. D is our answer. All right. And then it says last one, grade 11 had the greatest relative frequency. No, grade 9 had the highest frequency. Grade 11 was next highest, but grade 9 had the highest. All right, moving on to 11 and 12. The following segmented bar chart shows the number of flights that are either on time or delayed at 3 different airports on one day. All right. Which of the following statements is supported? In other words, we're looking for true statements. All right. And we're dealing with not relative frequency. We're dealing with the number. We're actually dealing with real counts. All right. Airport T has the greatest percentage of on-time flights compared to the two airports. Well, how many planes are there? Well, it looks like there's a total of 500 flights because I just draw a line across. That's about 500. And they have 200 out of 500. What is that? Because these are the on times. 200 divided by 500. Oh, and we're looking for a percentage. So I multiply that, 200 times 100 divided by 500. And this is about 40%. So 40% of their flights are on time, 60% of theirs are on time. When I look at S, I go, well, they had 200 total flights and 100 of them were on time. So without doing a whole lot of math, I can just look at it and go, this is half, so this is 50%. So this is 50% and 50%. And this one looks like they had, if this is 100, this is going to say this is 150 flights. And we know this is 100, so 100, this is going to be 100 out of 150 flights equals X over 100. Always multiplying the two numbers on the diagonal. So about 67% of their flights were on time and 33% were not. So let's take a look at this. Airport T has the greatest percentage of on-time flights. False. They had the least. Airport R has the least percentage of on-time flights. No, airport, that's false. They had the greatest number. And by the way, we're looking for true statements. The number of on-time flights at Airport S is half the number of flights of on-time airports at Airport T. Well, how many were on time? Well, at this one, it looks like it's about 100, and Airport T is 200. Yeah, so S is half. 100 is half of 200, so that's a true statement, and that's my answer. All right, last one, moving on to number 12. The following bar chart displays the relative frequency of responses of students by grade level. Do you volunteer in a community service activity? So what it has is we have ninth graders. And by the way, these are percentages. When it says relative frequency, we're talking about percent. So 60% participate, 75, 75, and about 50% of 12th graders. Notice it doesn't say anything about the numbers. So we don't know anything about the numbers yet. So which of the following statements is not supported? So we're looking for false statements. We're looking for the one that's false. More than 60% of both 10th graders and 11th grade students responded yes. Both 60% and yeah, looks like about 75% and 75%. So this is a true statement, but we're not looking for true. We're looking for false. 12th grade students had the least percentage of students respond yes. I'm looking at that and I'm going, yeah, that percentage is 50% and it's less than all the others. So that's a true statement, but we're still looking for false, so that's not it. Less than 40% of 10th graders responded no. Well, if I look at this, it's like that's probably around 75%. So this is about 25%, definitely less than 40. So that's a true statement. And again, we're looking for false. All right, the number of 10th grade students who responded yes was greater than the number of 9th grade students. Maybe, but maybe there's 1,000 9th graders and only 100 10th graders. We can't talk about the number because the numbers were not given to us. They only gave us percentages because it was relative frequency. So the problem with that statement is we don't have the number because it's dealing with relative frequency, which is percentages. So this one, we can't make that claim. So that's my answer. All right. I hope this helped. I know this is a long one. Thanks for watching. I look forward to seeing you on the next one. Thank you.